Welcome to ACT Prep Day 34. Again, we are in the geometry section. So hopefully you have your bell ringer with you, or just use the screen and write it down on a sheet of paper, and you can take a screenshot to send in. So our bell ringer activity for today is talking about slopes of parallel lines, perpendicular lines, and just any line in general. And again, this is something that I've told you numerous times that you are going to need to know as long as you are in a math class. This is a really huge concept, slope and the slopes of perpendicular lines. So take about five to 7 minutes, pause the video, work on your bell ringers, and when you are done, unpause and we will check your answers. Okay, welcome back. Let's look at the answers for this. So the easiest thing to do here is to get this in y-intercept form. So we solve for y equals, and hopefully you all remember that the coefficient in front of the x is our slope. So this one is a negative slope, so we know it should be going downstairs at negative. And now they're asking for a line that is perpendicular to number 1. They just want to know what the slope is, and this is where you have to remember, if this is the slope for line 1, then if I want the slope of any line perpendicular, what do we do to the slope? We flip it, numerator and denominator, and change the sign. So instead of 4/5, it becomes 5/4, and because instead of being negative, it becomes positive. And then here, what is the slope of the line parallel? And you should know that the slopes of parallel lines are equal. So if you're telling me this line has a slope of negative 4/5 and this line's going to be parallel, I can determine that the slope will be negative 4/5. Okay, so today we are going to dive more into geometry with parallel lines, central angles and arcs, inscribed angles, and insided polygons. Now, this is one of my favorite geometry concepts. I love two parallel lines and a transversal. Now, you may be looking at it going, why? Because once you have the steps memorized, it's easy. And again, L and M are parallel. Excuse me. Line T is a transversal. And something really magic happens when lines L and M are parallel. It's very easy for us to find all the angle measures in this upper section. All we have to do is measure one of the angles. And I always tell my students, well, why? Why do we need to memorize this geometry? Take this intersection here, and instead of it being on your paper, think it's an intersection out on the road. It's a four-way stop, or there's a traffic light. And if I have to pay a company $5,000 an angle to measure the angles, do I want to pay them $20,000 to measure all 4 angles? Or would I rather pay them $5,000 and measure just one? This is where the geometry comes into play. Because I know my geometry well, I'm only going to pay $5,000. And those are the people that sit in the corner office, are the ones that can go, I can do that for $5,000. You think $20,000. No. And the reason is, if I know the measure of angle 1, I have a linear pair here, I have vertical angles, and another linear pair. So when L and M are parallel, even more amazing things happen. I don't have to go measure anything down here. I know that angle 1 is congruent to angle 5. They're corresponding. Angle 3 is congruent to angle 7. 2 is congruent to 4, and 4 is congruent to 8. So here's 8 angles that I could 100% accurately measure, but only paying for someone to physically measure one. Now, when we start talking about quadrilaterals and parallelograms, they are made up of parallel lines, because a rectangle has opposite sides parallel. A parallelogram, they're going to be opposite sides parallel. And we have lots of things underneath parallelograms, rhombi, squares, trapezoids have parallel lines. Yeah. Here's an example. This looks like a parallelogram. So we have two opposite sides that are parallel, and we're going to be able to use a lot of these properties from parallel lines that are transversal. And this is the part that I absolutely love here. Let me erase. It says if the measure of angle 2 is 73 degrees, find all the others. Now, my favorite angle in geometry is vertical angles. Why? Because it's easy. If this one's 73, what's this one? Because it's vertical. 73. Now, to find angle 1, I need to understand they're a linear pair. Angle 1 plus angle 2 should equal 180 degrees. So 180 minus 73 is going to give me 107. Guess what? Linear pair. I'm pretty much done with the math. If this or vertical angles. If this is 107, this is 107. I got to do the other four. But line L and M are parallel, so corresponding angles. If 1 is 107, what is 5? 107. Again, vertical angles. Here I have so many options here. I can say 2 is corresponding to 6, so it's 73. I could say angle 4 plus angle 6 are supplementary. They're same side interior, therefore they're equal to 180. And again, I tend to use vertical angles whenever I can. This is 73, this one's 73. Why? Because they're vertical. But I only paid, oops, not that one. I only paid to get the measurement of one angle. That's why geometry is important. Sure, on paper you can take a protractor, but there's not a protractor big enough to go out there and measure the angle of a road intersection. It takes fancy equipment and it's expensive. And when you get into the business world, you want people making decisions that can save your company money. And here they're just going over what I just did. Okay. Now let's get into central angles. A central angle is named because the vertex is at the what of the circle? You're right, center of the circle. Okay. Erase this. Now it's very interesting because we would call this arc AB. Okay. We would call it arc AB. The legs of the angle are the radii. Each one is a radius. And they intersect the circle at two distinct points, A and B, therefore creating this minor arc here of AB. And we would actually name that, you do 2 capital letters and you put an arc over it. Now, just like a line segment, we could call this arc AB or we could call it arc BA. It's not going to make a difference in our measurement. Now, the thing to know about central angles is if this arc has a measure of 80 degrees, this angle is going to have a measure of exactly 80 degrees. They're going to be the same. Okay? It's going to be the exact same. If this is 80, this one's 80. If this angle is 80, this arc has a measure of 80 degrees. Okay? Now, if we want to find the actual measurement, not just in degrees, but how many feet, how many inches, okay? You're going to take the central angle divided by 360 because we need to get what portion of the circumference this 80 degrees is. And once you do that, then you're going to multiply it by the circumference. Because as we've got in this one, oops, let me go back. I apologize. 80 divided by 360, I think you get 45. 1 over 45. And so you're basically doing 1/45 of the circumference. Now, inscribed angles. These are different because the vertex is no longer in the center. It's on the circumference. It's inscribed about. The circle is on the outside and the angle is on the inside. Now this one's actually really easy too. Remember, if we had this central angle here, what would this measure be? Oh, it would be 100 degrees because arc AC is 100. This is a central angle. The angle is 100. So let's look at angle X. We know it's not 100. It looks like it's less. What does it look like it's less by? Looks like it's half, doesn't it? And it is. We can actually do a formula. We can prove that angle X is half the measure of arc AC. And that's where we get our formula. It is going to be half. So if arc AC is 100 degrees, angle X will be 50 degrees. And it goes both ways. If angle X is 30 degrees, then the arc would be 60. We just double it. Yeah, 50 degrees. Yay. Now, this is a concept you need to understand. This figure here, you're probably going, oh, okay, it's a circle and it's got a line stuck to it. This is what we call a line is tangent to, line L is tangent to circle C at point T. So this line only intersects circle C at point T, okay? Now, if we drew a line from C to T, what would we call that? It's a radius. Okay? It's the radius of the circle. Now, what would be the measure formed right here? And I'm kind of giving it away. It's going to be 90 degrees. If a line is tangent to a circle, then when you draw the radius to that point, it forms a 90-degree angle. And instantly when I hear a 90-degree angle, I'm thinking, ooh, right triangles, Pythagorean theorem. And then the last one is asking you, it's a little off topic here, but what is the longest chord that divides the circle into two semicircles? That's our diameter. It goes through the center and it will be the longest chord on any circle. Now let's talk about inside of polygons. This is a formula that you should know. And a lot of students don't understand where it comes from. So I'm going to give you a way to help you remember what the formula is. So if I have a triangle, okay, we already know that the sum of the interior angles is equal to 180, right? Okay. And if I asked you how many triangles could you cut this up into, you would say 1. So it would be 1 times 180. Now let's go with a four-sided figure. How many triangles can you cut this up into? You can only start at one vertex. I can divide this into 2 triangles. So I've got 2 triangles. If I sum up all the angles, that's 2 times 180. And if we go to a 5-sided, 6-sided, you're going to see there's a pattern here. There's a huge pattern here. And so this is where we get our formula. Because 1 is the number of sides, which are 3. 3 minus 2 is going to give me 1 times 180. 4 minus 2 gives me 2 equals 180. 5 minus 2 means I've cut it up into 3 triangles times 180. 6 minus 2 gives me 4. I can cut a 6-sided figure up into 4 triangles. And that's where that formula comes from. And again, I always explain it that way because that's what helps me remember. If I forget, oh, let me take a quadrilateral, I can only use 1 vertex, I can cut it into 2. 2 triangles, so 4 minus what equals 2, and I get the n minus 2 equals 180. Now, you should know that the angles of a rectangle, you should have that memorized, that they add up to 365. Okay? You should. Now, if we're talking about a pentagon here, pentagon means how many sides? 5. So we should be able to find the sum. So 5 minus 2 times 180 means 540. Now, something special happens here. When a figure is regular, this means, when we're talking about polygons, all sides are congruent and all angles are congruent. Then we can go a step further and find the measure of each individual angle. But it has to be a regular polygon. And so what we do here is we take 540 divided by the number of sides. So that would be 5. Each interior angle is worth 180 degrees. Now here's our ACT example. You're given that line L is parallel to M. We have transversals V and W. Point Y is on line M, and the measure of ACY, so I'm going here, ACY is 125, and BAC is 70. They want to know how many angles will have a measure of 55. Okay, take a few moments, pause the video, and see what you come up with. Okay, welcome back. Let's look. Again, I'm going with my very favorite ones first at vertical angles. If this one's 70, then this one's 70. This is 125, then this is 125. And then my second favorite would be linear pair. Okay, 125 plus this angle is going to equal 180. So 180 minus 125 is 55. Here we've got 55. And there's so many different routes I can go here. There's so many that I can do. Here I can do the triangle angle sum theorem. 70 plus 55 gives me 125, and the three of them should add up to 180. So I know this one's 55. Vertical angles. Linear pair here, I determine these are 125, 125. And now you're probably getting up here and going, oh, how do I do these? Okay. Well, I want you to just look at, I'll go blue here. Okay. We've got lines L and M, and I want you to just look at transversal F. So we got L and M. So 55 here is going to be corresponding to this one. So I'd be able to say 55 degrees here. And now I can go so many different ways. I can do that same thing again, but 55 plus 70 plus unknown equals 125, and I can solve and find that's 55. So vertical angles here, this is 55, and vertical angles here, this is 55. Yeah, these are like little puzzles you can solve. And so when you count them all up, you're going to end up seeing, they got the same answers I did, that there's 8 total. 8. Okay, 4 questions today. Use the online stopwatch or set a timer on your digital device. Pause the video for a moment and come back when you are done answering the questions for the answers. See you in a few. Okay, welcome back. Let's check these answers. Here we've got lines L and M are parallel, and they're intersected by transversals S and T. Given the angle measures below, they want to know what X is. Okay. This one, again, it can be done so many different ways. Probably the one that I'm going to do is I'm going to focus on this transversal. And if this angle is 70, then that means this little one in here is 70 degrees because they're corresponding. Now, X plus 70 make a linear pair. So 180 minus 7 gives me what? 110. You could have gone, if this is 70, then this one's 110 because they're a linear pair, and then said corresponding. There's so many different ways that you can go about solving and getting 110. Here we've got one. You've got AB is parallel to CD, and I put my marks in all the time. Angle BAC is bisected by AE, so that means these two will be congruent. And then CE also bisects ACD. Okay, I've got 2 congruent ones here. So when I find one, I have the other. And then they're saying the measure of ACD is 86 degrees. And I do this when I have an angle that's been split so that I know the entire thing is 86 degrees. And if it's 86 degrees, then if I divide that by 2, each one of these are going to be, what, 43. Yep. Okay. Now I'm sitting here going, where do I go? Remember, we have parallel lines. So if this angle is 86 degrees, this angle will be supplementary to it, CAB. So 180 minus 86 is going to give us what? 94 degrees. And if the entire angle BAC is 94, then that means each one of these are going to be 47. It's kind of hard to put it in there. Well, now I know I got 43 degrees here, 47 degrees here. I can add those together, subtract by 180, and get the measure of AEC like they asked. And it ends up coming out to be 90 degrees, a right angle. Yay! Here we've got a hexagon, and we know that A is 85 degrees. So what's the total measure of the other 5 interior angles? We cannot determine single ones because this is irregular. This is not a regular hexagon. You need to know that hex means what? 6 sides. 6 sides. Always remember hex, it has an X, 6 has an X. And our formula is n minus 2 times 180 to find the sum for all of them. So it's going to be 4 times 180, which ends up being, what is that, 720? And they're wanting to know what's the measure of the other 5 angles. Well, all we have to do now is subtract 85 from it, and you end up getting 635. And the last one here. Here we have a circular container. We have a radius of 6 inches. And there is a zipper. The zipper goes around the outside and then back here. Okay? So it forms this wedge-shaped flap. If the zipper is going to go along the one side of the wedge-shaped flap and then around the arc, what is going to be the length of this zipper? How long does it need to be? Okay? Well, this is really kind of cool on how to do it. We know that if this has an angle measure of 60, what is this one right here? It's going to have a measure of 60 degrees. Okay? We already know this one's 6 inches. And right now, I can already tell you, okay, it's not 6.5. Yeah, because I got to find out how long this is. So now, here's what you're going to do. Remember that formula to find the length. It is going to be the degree of the arc divided by 360. Oops. Times the circumference. So the circumference is going to be 2 times pi times the radius, which is 6. So now we're going to get 1/6, and this is why I don't like to use calculators, because look how this is going to cancel out here. Times 12 pi is going to give me 2 pi. And now this is probably when the calculator can come in handy. You can do 2 times pi plus 6 inches. I don't have a calculator with me, so I'm going to cheat a little. I know pi can be rounded down to 3. So what is 2 times 3? 6 plus another 6 is going to give me what? Around 12. And I rounded down from pi, so my answer should be more than 12. And your answer is going to be 12.3. A little logical reasoning in there. Okay, we are done with day 3.4. So now I want you to do your exit ticket. And the exit ticket pretty much is wanting you to explain the difference between a central angle, the formula for a central angle, and the formula for an inscribed angle. And so basically, if they're telling you arc BC is equal to X degrees, and we have an unknown, what is going to be the measure of angle P, which is your central angle, and angle A, which is your inscribed angle. And they're both inscribing arc BC. So hope that you had fun and enjoyed this lesson, and we'll see you for the next one.